Captain's log, stardate 41153.7. Our destination is planet AppSec, beyond which lies the great unexplored mass of secure code. My orders are to examine the news and what's been built there by the inhabitants of that world. These are the episodes of the podcast ASW. Its continuing mission? To explore strange new clouds, to seek out new life and new DevOps migrations, to boldly go where no one has gone before. Which means, this week we talk with Shubhra Kar from the Linux Foundation about building a culture of security and launching security initiatives within open source software projects. In the news segment, how to print an apology, how to SN printf a vulnerability, BlackBerry visits the bad Alex sector, proxy logon opens hailing frequencies, and more. Set phasers on stun and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shift-left. In any business today, there comes a moment, the moment you realize you can secure the code as fast as you write it. Instead of testing everything, you can just test the right things. It's not about tools, but intelligent risk management. That's the moment you choose Synopsys. Build secure, high-quality software faster. Visit securityweekly.com/synopsis.
This is episode 163, recorded August 23rd, 2021. I'm your host, Mike Shima, and I'm here with John Kinsella, beaming in from, I'm not sure where you are this time, but hello, John.
I'm back in Seattle. I had to escape all the fires in California, so much burning going on down there. I feel for everyone. I hope everyone's staying safe and healthy, and we had the chance to escape, so we did. And I have to ask, did you actually use the stardate calculator to double check that date, or did you make that up?
So there is the stardate calculator that I have the stardate for today at this episode time that I may reveal later, but that was technically the encounter at Farpoint stardate. So that was the throwback to episode 1 of the TNG. And it's also the August 19th, Gene Roddenberry's 100th birthday. So another reason to sneak that one in, but thank you for noticing. Other things that you might notice, dear listeners, is that Cyber Risk Alliance, in partnership with InfraGard, has launched the Critical Infrastructure Resilience Benchmark Study. Measure your readiness for ransomware by completing the survey and getting your score. Visit securityweekly.com/CIRB to take the survey. InfoSec World 2021 is proud to announce its keynote lineup for this year's in-person event. Hear from Robert Herjavec, plus heads of security at the NFL, TikTok, U.S. Department of Homeland Security, Stanford University, and more. Plus, Security Weekly listeners save 20% on World Pass and main conference registration. Visit securityweekly.com/ISW 2021 to register now. Shubhra is a passionate technology leader with over 20 years of experience in open source, cloud, enterprise architecture, DevOps, IoT, and real-time monitoring and analytics. His career spans early-stage startups to NASDAQ-listed companies generating nearly $10 billion plus in annual revenue. He is a bottoms-up product leader with previous lives as developer, enterprise architect, management consultant, pre-sales director, and chief evangelist before finding his calling in product management. At the Linux Foundation, Shubhra created the LFX platform, which we're going to hear about in a little bit, with services for every stage of the open source supply chain. He also runs the cloud and release engineering team, serving 700 open source projects. Hello, Shubhra. Thank you for joining us.
Hey, Mike. Thank you for inviting. My pleasure to be on the show.
Well, it's our pleasure to have you because you have quite a varied background, and you're doing quite a lot within. Of course, supply chain is on everyone's mind in 2021, but you're doing quite a bit more than that. Especially, working with over 700 open source projects. So I think there's a lot to cover there. But why don't we go on what's perhaps most topical right now, and supply chain in open source software, and what does that mean? Because it's a pretty big topic, and I'm going to guess off the bat that open source projects don't really have a engineering budget necessarily that they can start to apply to engineering resources, tooling, etc. So with that kind of challenge laid out for us, what's your approach to making things better?
Yeah, absolutely. The interesting part is open source projects at the LF. We have 700 projects. We don't have a budget, but we have 1 million engineers. Those engineers work across the world at large enterprises, small companies, very distributed, a lot of sprawl, different processes, different methodologies. Now, the challenge for us is how do we get them thinking security first? Because the Linux Foundation is home to all these upstream projects. And a line of code or a byte that's not secure, that gets injected into the upstream code, there can be millions and millions of downstream downloads of that within the large enterprises. So security is top of mind for us. And what we have done is we have taken a multi-pronged approach. Security has been a top topic for us for the past decade. Originally, we started initiatives like the Core Infrastructure Initiative called CII. And the goal there was to enforce or ensure there are best practices followed across open source projects in terms of tools, security audits, whatnot. And we had roughly 4,000 projects who got certified at different levels in the CII program. And every project got a badge, a digital badge around gold, silver, platinum passing. Now, beyond CII, beyond best practices, what we have recently started investing in is a lot of tooling. So, as the housekeeper of all these projects, it's our intrinsic responsibility to make that these projects are secure. So we have invested in a lot of tooling. We are partnering with a lot of vendors in the ecosystem, different SCA vendors, and we are able to generate reports for the community at large around areas around vulnerabilities, areas around non-inclusive language in the code, areas around where code secrets might be exposed in the open source project Git history as well. And we are publishing these metrics for everyone to take action upon. Because what happens generally in open source is most developers are focused on the next release and getting new features out. And security usually comes as an afterthought, finally, when the open source code base gets downloaded within the enterprise behind the firewall. And what we are doing is move it left. I would say move it up the stack. When we start thinking security first, starting with every release, we want to have developers look at these different kind of issues that are reported, harden their code, and even make it part of their graduation criteria. So new open source projects, before we call it a mature open source project, we are setting some guidelines based on these key KPIs around security.
So it's a great evolution, because I think a lot of CII, if I recall correctly, is much of it is self-reporting. It's the idea of what processes do you have in place, what do you have in place, and just our projects, reporting that they do so. Whereas now it sounds like you're adding some tooling to be able to sort of check and verify, but provide more information. And a lot of that information is vulnerabilities that exist. So you mentioned that you've got quite a few, 1 million plus or so, engineers working on open source. But how do you get those engineers to commit to fixing vulnerabilities? Because even coming from the enterprise world, fixing vulns is not an easy thing, and that always feels like a struggle with security teams. So help us out with some ideas or some paths to success for making vulns go away.
Yeah, no, absolutely. So we don't have the silver bullet yet, but here's a few things that we are doing, right? One is we have started a bunch of benchmarking exercises in terms of, obviously, weighing how mature a project is and the size of the community as well as the adoption of the community. And every release we scan, and continuously every day we reports whether the vulnerabilities are going up or down. And based on these benchmarks, we tell you like, okay, this is a good project. This project needs to improve, and any project that is coming in, they can benchmark against that project, right? And we are creating scores. Think about like security index scores. Now they're based on, these scores are based on a bunch of criteria. They are not just flat counts based on the number of vulnerabilities. We are rather creating these scores based on the number of vulnerabilities that the developers are fixing. So we really want to create leaderboards of projects who are actually taking an initiative in fixing these issues. So we give them all kind of digital badges and certifications, as well as put them on a proper leaderboard. That's number one initiative. Second thing that we have done is whenever a new project comes into the Linux Foundation, we have different stages of evolution. We come all the way from a sandbox project and an incubating project, then we move on to a graduated project. And over some time, right, when it kind of matures out, it could plateau. So before you make the cut that, hey, I am a mature project, we are tying these KPI metrics about the rate at which you are fixing vulnerabilities. Vulnerabilities can never be zero. We get that. Every new vulnerability will inject more and more defects. But we are giving you a score. We are computing these scores that you can attach to your maturities of the project, right? That's number two. Then the third thing we are doing is it's also about talent and also a shortage of people who are going to fix the bugs. So if you look at a project, there could be 100 contributors, but they may not even have bandwidth, and they might be working at another enterprise company and maintaining this project part-time. So we are giving funds to these projects to create mentorships where they can organically hire from different colleges, or people who are new to the project. They go through a mentorship exercise for a few months. They graduate, and the focus of those mentees is to actually address and fix these security issues and move the project forward.
There's a lot of cool things to that. One, of course, I love the aspect of the emphasis on the rate of fixing or the velocity of fixing, rather than just saying you've got a lot of bugs or you only have a few bugs. It's sort of it shifts to I think things that that the developers can influence better. It's sort of like shifting away from just talking about lines of code. That can be a contributor to complexity, or just say how much effort needs to go. But it's not, I think, as informative in terms of from a security perspective, I guess is what I'm trying to say there. And the second part you were saying too, just at the end, the mentorship, that ties into something that John has actually brought up in the past too, about what should we be teaching people in colleges? What are some AppSec or just some good general comp sci principles? I'm kind of curious there as you have this program and bringing in people to fix vulnerabilities. Is there an easier way that you've seen to introduce them to areas of code or particular vulnerability classes? Or tell us a bit more how that process has been, and maybe what are some ways we could continue to improve that?
Yeah, very, very interesting. So I think we have multiple approaches that work for us. Number one thing is we need to create a bug backlog, right? So the tools scan, but a lot of these tools also present false positives. So number one thing what we have done is we have created like some regex patterns in our tooling, which let you dismiss these false positives and you get a proper bug backlog. Another way what we are doing is we are providing funds to these projects via mechanisms like crowdfunding, where they can run hackathons. And we have partnerships with various hackathon providers, where essentially we are creating a well-curated list of real bugs, right? So that's number one. Now, as these mentees come in, we do two things. Number one, we actually provide them free of cost training that has been created by the open source project communities themselves during their mentorship period. And a lot of focus on that is around application security. In certain cases, like C++ or C, if you look at the Linux kernel itself, it's all written in C. You don't really have dependencies, and you're operating at the root level. So where you might have to do a lot of static code analysis to actually find out what's a vulnerability or not. So we actually have courses for those that we teach online, and we give certification exams. But in addition to that, every mentee that's coming in, we are pairing them with the maintainers of the project. Now, the maintainer definition for us is someone who is some of the most senior developers in that open source project, who maybe earlier created the project and have been reviewing, doing code reviews, merging the code, looking at it, and hold the technical responsibility for the health and the sustainability of the project. Now, as these mentees learn from the top maintainers, over 3 months' time, they graduate and develop enough skill set. And during the mentorship period, the maintainers assign them tasks to work on specific issues that are on Git, to go and fix certain vulnerability bugs, or to do actually a lot of quality analysis as well, and deploy and try to reproduce them as well. So this is a continuous cycle. And once those mentees graduate, our goal is to convert them into contributors, long-term contributors of the project. So whatever they learned does not go away with their mentorship ending, right? They should be involved in the project long-term.
No,
I'm curious, what type of feedback are you getting so far from it? You've been running some of these programs, I know longer than others, and I just pasted the LFX website into Discord for people who want to take a peek. But I'd be really curious to hear, what type of feedback are you getting from people who are going through this program? Are they excited about it? Do they want to learn more about security? Are they like, okay, we've got that, now we can go back to coding? Or what are you getting from folks after this?
Yeah, it's a mixed bag. I think there are certain people who are like fresh and they're just excited to learn the technology from the best in the industry, right? And get an industry certification, maybe even pursue a job, right? On that open source project itself. However, there is a certain set of people who maybe have experience previously, not fresh off college, but actually have a little bit of a security background. And some of those folks have been active participants in what we call as the special interest groups, or SIGs, or working groups within our open source projects that are focused around security. So just in 3 months, you can't become an application security expert, but they're getting the foot in the door and they get involved in these active conversations. And they actually work on some of the initiatives that the SIG is pushing year after year.
And it sounds like a great experience that can translate to enterprise software as well. Not to say they have to depart from working on open source, but you made the point that a lot of enterprises are the ones that are actually contributing engineering time to these open source projects. And I think a lot of the vulnerabilities that come up, those come out of developer mistakes, patterns that are being used within open source that could easily be used within enterprise software as well. So I think there's a great message there, I think, underneath that's saying that finding vulns, fixing vulns, understanding and doing that analysis translate to any software you're writing, not just open source.
Yeah, no, absolutely. You've got a great point. So I'll give you one example. So in some of our tooling, we have started detecting code secrets. And you would be surprised, and this is true for any enterprise company as well. As you go through the software development lifecycle, you might put in passwords or secret keys for, your API keys for a cloud platform. And you might think like, okay, I'm making this, putting this key in a commit, and 10 commits downstream, I'm going to delete it. Or I'm going to refactor the code, and whatever I get pushed to the master that goes into the final branch is not going to have this. But guess what? Your git commit hash has all the history of all these secrets. And you're essentially not just putting yourself at a risk, but what if those secrets, you're working at a large enterprise company and maybe your AWS accounts are linked to that company and you're contributing to open source. If those secrets get passed on or picked up by hackers, you're essentially putting your company at risk as well, right? So it's multifaceted, because you're absolutely right. We ran a survey and we found out against our developer base, we actually do deep instrumentation of who's writing code and where do these people work at. And stunningly, more than 80 to 90% of our contributors in that million-strong community work for enterprise companies. So it's a sort of a myth that got busted, where we thought like open source is completely like freelance. It's actually not.
No, it's wonderful to be able to point to data like that. I want to shift us now to from the conversation. We're talking about a lot of vulns and just getting rid of vulns and just in software in general, and of course in open source software specifically is what you're building the tooling, building the accuracy for. But there's also the aspect, if we have the call back to supply chain about what open source packages am I running on my systems, what third-party dependencies I'm pulling in, and this leads us into SBOM. So I'm kind of curious, how does SBOM relate to the vulnerability work you're doing, the security work you're doing, and how do you pull in this type of approach of saying, this is what my software looks like for these projects, both large and small?
Yeah, no, absolutely. And, so at the Linux Foundation, a decade back, we had a project that got in, that was in inception stage called SPDX. And it was essentially a language or a protocol for understanding how a project is constructed in terms of licenses, in terms of packages, files, dependencies, and so on, right? Now, what we did was, it was a specification. We didn't really have an actual implementation of the spec. And we had some plugins which actually help you create a software bill of materials. Now, recently, we had a big episode where, we had a big hack happening in a critical infrastructure project. And the Biden executive order was out there where, open source software, because it's mainstream now, there needs to be a proper software bill of materials created, a document created, which actually defines who wrote the code, what does the code consist, what are the packages that you're using from upstream. Because nowadays, if you look at software, you only write 10 to 20% native code. 80 to 90% of your code is borrowed. You're borrowing code from third-party libraries, other packages, based on your package manager. So in our tooling also, what we did, we actually scan all the dependencies and start building this application dependency stack. Now, we could be looking at static dependencies based on your manifest files. We look at runtime and transitive dependencies. And we start looking at vulnerabilities around all those areas, right? And the point could be you might be as strong as the weakest link in that chain. So we try to narrow it down. And then we essentially recommend, like, hey, is there a quick fix available for this or not, right? But as we start packaging this, we actually productize the SPDX format. And we created generators across all languages, across all platforms. So you can point at an open source project and say, build me a software bill of materials document. And it looks into 16 mandatory key parameters, which define which are like the minimum that we need in the framework, which defines what is the document type, the author, who created it, what libraries you use, what packages you use, what is the license you use, what files you use, and it actually gives you a construct of a software bill of materials. Now, within an enterprise, if you're all writing proprietary code, you know what you're writing. You have different ways of doing that analysis. But in open source, particularly even within the enterprise, because you're using software from across the world, you need to have a definition of what exactly is in your package, right? What exactly comprises that bill of materials. And so that you can, put guardrails around it. And if there are vulnerabilities associated in those dependencies, you can fix them. If there is reporting you need to do, you look at like the vendor ecosystem, or maybe, prevent malicious actors from putting code, you can identify those people as well.
Yeah, it sounds like it's just a way, especially standardizing makes it more machine readable, easier to parse, easier to scale, just to answer the questions, the basics problems of asset inventory or application asset inventory. In this case, in particular, third-party libraries, dependencies, etc. One of the things you've been talking about too are who writes the code or who's authored the code. And clearly there's, open source brings maybe some special considerations in terms of anonymity or how much anonymity there should be or trust in the process. Tell us a bit more about, how you see that from, what security initiatives you might have going on, or how you start to address that from an open source perspective.
Yeah, no, very important question. So I think we look at it from different perspective. One is like, I think the question comes down to developer identity, right? Like any web presence you have, any online presence you have an identity, and think about like you're doing an online banking transactions, mission critical is tied to an identity. Now, if you're writing code, if you're just doing it for a hobby, maybe you don't care. But because your code is shared, you inherit a responsibility of having the accountability for that code, or even there are people collaborating on that code. Now what we found that earlier in the days, like if you're in Git, we need to have an identity, but those identities differ: who is making the commit versus who is authoring it, who is reviewing it. But there are multiple source control systems where you could make an anonymous commit. Now, this insert in recent history has started causing a lot of problems for us. When there were some folks in the community, they took it as a science experiment to inject malicious code into the kernel itself without actually giving us the identity. Now, we had to actually go and reverse engineer millions of lines of code to find out who injected that malicious code base, why did they do that, what and where did they work, and then we had to work with their employer to have them flush that code base out of the system itself. And some small effort like that can cause rippling effects across the entire community. Now, in addition to this, like developer identity, right? Like you could be using n number of emails, right? You could be using Git, GitHub. Maybe you're not just writing code. Maybe you're writing documentation. Maybe you're, using Discord or Slack in your case, right? And you're contributing to the project in some mode or fashion, right? How do we stitch all these identities together? So earlier, at the Linux Foundation, we had created a unique identifier called as the Linux Foundation ID, at least for the projects which find home at the Linux Foundation. We are stitching all these together with developers' consent. And we give developers the way to merge their identities. But another thing we are also encouraging them to do is to update their affiliation. Who are you contributing code on behalf of? Are you contributing code as yourself, as an individual or a hobbyist? Or are you actually contributing code on behalf of an employer that you're working? What it lets us do is doesn't just let you manage the liability, or your company actually has, if they have to sign a corporate contributor license agreement, they can do that. But it also makes sure that a company who's investing thousands of developers in enterprise can actually look at like what value they are generating, right? And it encourages them to put more investment. So, but again, developer identities, it's not solved yet. We have been looking at distributed, blockchain versus, other projects as to create a distributed identity model. There isn't a global spec for that yet, right? So we have stitched together identities at the LF across different data sources our community uses, be it Slack, Twitter, GitHub, whatever it is. But we still want to solve the bigger problem.
No, and sounds like that there's bigger problems both on a call to action from enterprises or to how to, I guess, let me rephrase my question this way. What are some calls to action for enterprises? How can enterprises be better participants within the open source community? And then the second part is, what about on the same question, but on the individual side, whether it's just updating their identity or doing something else within an open source project?
Yeah, I think that a clear call to action. I think for the developers, the clear call to action is, see if you can avoid making anonymous commits or anonymous comments. There's no shame in tagging, right? Like you're not going to gain anything by writing secret code. If you're concerned about your identity being used or your email ID being out there, well, you are online, your identity is already out there, right? If you're using any social media or wherever, your identity is already out there. You should help the community recognize like who you are and why you are so important. For companies, I think it's, for them, it's interesting that, if they are using tools like contributor license agreements, then, they have their developers route their the CLAs for their corporates to sign so that they can take care of the legal coverage that a company can provide across all its contributing developers to an open source project. Not that we are encouraging signing CLAs, the industry is moving towards developer certificate of origins, but from a corporate responsibility perspective, that's a good tool to use. The second thing is obviously encourage their developers to not make anonymized commits, to actually, use an ID. It could be an email, doesn't have to be a corporate email. Even if you use a Gmail or some other ID, at least make sure that you do some affiliation. So we are providing these tools. There are different ways. You just don't have to use the tooling the Linux Foundation use. There are tools like Git DM that have been used in the projects like the Linux kernel or Kubernetes from a long time, where any developer who makes a commit or a pull request actually provides information on whose behalf they are putting that pull request for and what is their identity. So there is it's based in the developer tooling itself. So it's as easy as it can get. But I think it's just more of a community hygiene, which will let us go there. It can't be done by just one single person running a simple tool.
So speaking of tools, you've been talking or mentioning a lot about LFX and that tooling. Give us a little bit of a hint or some description of what the future holds for LFX.dev and the tooling around that.
Yeah, absolutely. So LFX was created as a cloud platform strictly for open source developers, right? To manage the entire supply chain as well as to get deep insights into how a project is moving in terms of its, like, how does it pipeline look like? Do I have a maintainer issue, burnout issue? Am I creating enough code? Is my enterprise adoption suffering? Is my project healthy enough? Am I getting enough downloads? Are there enough people speaking and evangelizing my open source project to the entire community, right? So we created a bunch of services, everything starting from fundraising. You have a new project and you need to raise funds to grow your project. So we created a crowdfunding service. You need to grow your talent in the community. You can't just poach people from other projects. So we created a mentorship platform. We created a security platform. We created a deep insights platform, which looks and instruments every digital endpoint that your application, open source application uses. We look at community statistics as a whole. Who are the top contributors? Who are your recent people who came to their community? Who are people who are abandoning your community? How can you actually help bridge the gap? How can you look at the health of your application? And how do you put them on a growth trajectory? Can you replicate some of the best practices, some very successful projects like the kernels and Kubernetes have taken, and get on the same growth curve, right? So we have been building a bunch of these tools. Similarly, we have built a training program. So if the open source project wants to grow the skill set of its community, they can come and publish training programs and certification exams so that they can get industry neutral certifications. You can do all kind of events. So if you look at like meetups or you want to do like formal events, we have created an events platform. So all of these services we are packaging in that cloud platform and providing to these open source projects. So soup to nuts. But another thing that's often bypassed is operations. So you get a project coming in early, go through the formation stage and it's up and running. But how do you scale it? How do you run the day-to-day operations? Your hosting, your CI/CD processes, your automation, your marketing campaigns that you might want to do for growing your project. So we have created another platform called the Project Control Center, which gives the keys to the maintainers of these projects to actually grow their platform, right? So we are investing heavily. I think going forward in 2022, we will be looking at a lot more AI-driven predictive analytics around looking at trends. What makes successful projects successful, right? If you turn a knob for a certain parameter, maybe it's create your more download channels or your registries. Will it actually improve your download rates or not for your open source projects? So we are going and investing in further toolings which will help you do that. Plus, a lot of investment will happen in security. So we have just started scratching the surface. We created an open source security foundation. And at the Silicon Up, we also have another initiative called the Confidential Computing Foundation. So we're looking at merging those and productizing and making them easy for developers to use at large.
That's awesome. I love the data and the analytics or the insights that you provide on the LFX.dev, as well as the promise of confidential computing. I think perhaps as you've perhaps described before, security from Silicon Up. So that those both sound like wonderful projects that give us a good future for open source communities.
Yeah, absolutely. Yeah, for us, it's a marathon. Right. I think the better we can educate, and we're also seeking help from not just large enterprises, but also around the SCA vendor ecosystem. Open source, it's it should be free. And, people should provide services for these projects out of the gate. And so we are working with a lot of partners in the ecosystem as well to make these free of cost available to all our communities at large.
That's awesome. Well, I know you're running a marathon. Unfortunately, we're only running a 30-minute sprint, so to speak, and our time is coming to an end here. But I do want to say once again, thanks, Shubhra, for joining us.
No, absolutely, my pleasure, and would love to engage with this community. And please feel free to visit us on lfx.dev and engage in our different communication channels and be part of the community.
That's wonderful. Yeah, I'll just echo that, especially as a great opportunity for the mentorship aspect. For those of you wanting to get into application security is a wonderful chance. So thanks once again. I want to thank John and everybody who's been listening. To learn more about LFX, go visit lfx.dev and check out the work they've been doing. We're going to take a quick break now and return with news of the week.